Alright, this video is going to combine 2.2 and 2.4. It's kind of the same topic, but not really. So I want to kind of go over it pretty quickly, but not too quickly. So the objectives for 2.2, and if you want, just do this as 2.2 is one note, and then 2.4 is a whole new notes. Alright, so first one for 2.2, the objective is to identify, write, and analyze the truth value of conditional statements, and either write the inverse, converse, and contrapositive. Okay, there's our vocab. So first we need to know what a conditional statement is. And a conditional is kind of like a cause and effect. If this happens, then this will happen. And that's kind of what this is. So a conditional, go ahead and write this table down. A conditional statement is a statement that can be written in the form if P, and this is kind of an example, P is just something that may happen. Then Q is something that will happen. So like if it rains, then I will go inside. It rains would be P, I go inside would be Q. So the hypothesis would be the P part. The if this happens, we don't know if it's going to happen or not, so it's the hypothesis. So it's the P part. It's what follows the if. All right, the conclusion, which is what happens. So if the hypothesis comes true, then I'm going to go do this. That's the conclusion. All right, and it can be written kind of like this would be a way to do it. P, arrow to Q. This is just saying, this is saying it without words. Okay, but we will probably usually write it out in a statement, if-then statement. All right, a Venn diagram can also be used to where if this happens, then I go to the Q circle. So like if I fall in the P circle, that means I'm also in the Q circle, so I do both. All right, and that one's kind of weird, but we'll do an example on that in the classwork. All right, so example 1, I want you to identify the hypothesis and the conclusion. So if today is Thanksgiving Day, then today is Thursday. So the hypothesis is if today is Thanksgiving Day. Then the conclusion is today is Thursday. So we'll underline the hypothesis red, conclusion in blue. All right. So we don't know if it's Thanksgiving Day or not. But if it is, then it must be a Thursday. So that's the hypothesis. If today is Thanksgiving Day, then today is Thursday. All right. If P, then Q can also be written as if P, comma Q. Sometimes you don't need the then. Or maybe sometimes they'll put Q first, then the if statement. But this still is the hypothesis. Okay, if it follows the if, no matter where it's at, it's the hypothesis. Except in this one, which you will not see it, I can almost guarantee you, you will not see it written as this. P only if Q. So that means Q will happen only if P was true, and that gets kind of weird. I will usually write it as an if P then Q, if P, comma Q, or Q, comma if P. You may see implies, but it's not as likely. All right, many sentences without the words if and then can be written as conditionals. To do so, identify the sentence's hypothesis and conclusion by figuring out which part of the statement depends on the other. So if I give you a statement and there is no if or then, you can write it into an if or then depending on, you look at what part's the false part, or what part do you not know, what part could be a variable. All right, so then a conditional statement also has a truth value. So true for T, F for false. Truth value is going to be your first buzzword. If it is false, or it is false, only when the hypothesis is true and the conclusion is false. And that gets kind of confusing. If the hypothesis is false, but the conclusion is true, then it's a true statement. Then it's a true conditional, and that it gets really weird, and we'll go through some examples. So for example, if today was Thanksgiving Day, then today is Thursday. That is true. That's a true statement. Thanksgiving only follows on Thursdays. But if I said, if today is Thanksgiving, then today is Wednesday, then you know that's false, because that's something that you can prove not true. But if I said, if a chair is a lamp, then the cow quacks, that is a true conditional statement, and we'll write some of these examples out, just kind of listen through this. If a chair is a lamp, then a cow quacks. That is a true conditional statement because the first part is false. And that's kind of a weird concept to wrap your head around, but we'll do so many of those oxymoron statements like that to where you'll just think of it as being true. All right, so determine if this is true or false. If this month is August, then the next month is September. So is that true? We have January, February, March, April, May, June, July, August, September. That is true. So this is a true. And yes, I did have to write all those out to think about that. All right, which is fine. If you have to write it all out, if you have to draw some numbers down and some diagrams, that's totally fine. At least you're getting it right and not getting it wrong. So it said this, if false, give a counterexample. So what that means, if let's say this said, if the month is August, then the next month is October. September, October comes over here. And so if they said it was October, we would say false. Our counterexample would be September, because that's what's after August. All right, determine if this is true or false. If a cat is a bird, then 6 equals 2. This one is true. Because the hypothesis, let's underline the hypothesis, because this is false, it makes the whole thing true. Kind of like the chair is a lamp. If a cat is a bird, then 6 equals 2. It doesn't make sense, so it's true. All right, now we have a thing called a negation. And what a negation does is it just takes everything and makes it negative. Now, if something was already negative, then it makes it positive. So the negation of the statement P is, you would just say not P. And then it's written as the squiggly sign. The negation of a true statement is false, and the negation of a false statement is true. So if I said, today is Friday, the negation would be, today is not Friday. If I said, it is not raining outside, then the negation would be, it is raining. You wouldn't say it's not raining. You would just say, it is raining. All right, so now we're going to do some things with the converse, inverse, contrapositive. So this is just the conditional statement. This is just, it is what it is written in the form if P, then Q. This is just the standard symbol, and I'm missing the arrow here is what this needs to be. Okay, so this is kind of the symbol of how we could write it. This is the word-for-word definition of it. All right. Next, we have what the converse is, and this is one of our things that we have to do. So a converse means that we're going to take the statement and we're going to switch it around. So instead of saying P to Q, the converse, I switch the P and the Q, and I write Q first. So then Q is now the hypothesis. So it's like if Q, then P. All right. So the converse is you switch or exchange. That's what the converse does. All right. An inverse, and again we're missing the arrows here. Then inverse, you leave the order the same. You don't mess with the P and the Q, but you make them negative. So you invert them, you invert the meaning of them. You make them both opposite. All right, and then the contrapositive, and again, missing the arrow. Contrapositive is the statement formed by exchanging them, where you switch them. Notice how our original was saying P to Q. And a contrapositive means I've swapped them out for each other, switched them, so I'm saying Q to P. But I'm also inverting them, inverse, taking the negative of them. So that's the contrapositive. All right. So now we're going to write the converse, inverse, and contrapositive of these statements. All right, so this is the conditional that's been given to you. I'm telling you now, that's what's given to you. So when it's given to you, you're told that that's the conditional. All right, so first I want to write the converse. So converse just means I'm switching the red and the blue. So conditional was if an animal is a cat, then it has 4 paws. The converse is if it has 4 paws, then animal is a cat. All right. Now I want you to say the truth value of this. Now, when I read this, when I read the original, if an animal is a cat, then it has 4 paws. That's true. Now, when you do these, you don't have to think, oh, well, there's some cats that lose a leg, and so not all cats have 4 legs because some have 2 or some have 3. You're just thinking of the general definition of a cat. All right? So if an animal is a cat, then it has 4 paws. We're accepting that to be true. Now we're looking at this statement. If it has 4 paws, then the animal is a cat. That one is false. Okay, now this is still the converse. We still write it out. But the converse is false because there's so many other animals out there that have 4 paws but aren't cats, like a dog, for example. All right. Now we have the inverse. The inverse, I don't switch them, and I just make them negative. So I say, if animal is not a cat, then it does not have 4 paws. Now, is this true? Now, there are animals that are not cats that do have 4 paws. So I'm saying if the animal is not a cat, then it can't have 4 paws. Well, if the animal is a dog, then that dog will have 4 paws. So this one again is false. All right, and last we have the contrapositive. So I'm going to switch them and make a negative. So I'm going to say, if animal does not have 4 paws, then it's not a cat. Now, this one can get kind of confusing because you may say this is false too, but this one is going to be true. Because if an animal does not have 4 paws, then there's no chance that it can be a cat at all. Now, it doesn't say that it has to be a cat, it just says that it's not a cat. So if it doesn't have 4 paws, then you can eliminate cats from that category. So the truth value is going to be kind of hard to wrap our heads around, and we'll get there. But we're kind of just, you got to think outside the box, but not too outside the box that you're creating new boxes outside of old boxes. Now you don't know what's inside the box. All right? So think outside the box with these. Think kind of abstractly, but don't try to create, like I was saying with the cat example, with some cats have 3 legs because it loses one or something. You can't be too out there with this. You kind of got to just keep it simple. All right, that was 2.2. That says 2.4, but it's not 2. It says 2.2, but this is actually going to be the start of 2.4. All right, so 2.4, the objective is to write and analyze biconditional statements. All right, so these are all, I guess, going to say 2.2 at the top, but this is all 2.4. All right, biconditional statements, definition, polygon, triangle, quadrilateral. Those are your vocab. All right. When you combine a conditional statement and its converse, you create a biconditional statement. And what a biconditional does is you drop the if and you drop the then, and then you just write if and only if instead. So that means you're kind of combining this statement and this statement by writing the if and only if. And sometimes you'll see if and only if written as P, if and only if, Q. So that could be a way that you see it. Okay, this is supposed to look not like that. What this should read is P double arrow Q means P to Q and Q to P. That arrow is supposed to go there, there, and there. All right, and that's kind of what we just wrote. So that's kind of just something extra. All right, example 1, I want you to write the conditional statement and the converse within the biconditional. So we see the if and only if, so that means this is a biconditional. Now when I write this, the hypothesis is always written first, and the conclusion is always written second. Now when I go to write this, what I have to do is cross out the if and only if, and I'm going to pop back in the if and the then. All right, so my conditional is, this is the original where I put the hypothesis first. So if Cho is a member, then he has paid the $5 dues. All right. Now the converse is you just switch it, okay? So that's kind of why we're combining it with the last lesson, which makes the video a little longer, but we're saving a day of spending another whole day on this stuff. So the converse is you switch it. If he has paid the $5 dues, then Cho is a member. We don't know what he's a member of. We don't really care, but we just know he's a member. All right, and that's kind of cool. All right, so when I give you the biconditional, you take this part, you write it first, cancel out this altogether, and you just put it in the if-then form. Then to do the converse, you just switch the original. All right, for a biconditional statement to be true, the conditional and the converse must both be true. If one of them's false, then the biconditional is false. And I don't think we'll look too much at the truth value of biconditionals. We'll mainly just look at the truth value of conditionals and converse. All right, so to determine if the biconditional is true, we will go ahead and do this for an example, though. So a rectangle has side lengths 12 centimeters and 25 centimeters. If and only if its area is 300 centimeters squared. So what this is saying is that we've got this rectangle here, and this is 12 centimeters, and this is 25. Now, if I found the area, 12 times 25, I do get 300. So that's true. If a rectangle has those side lengths, then it should equal that. But is it necessarily true if the area is 300, then it has to be a 12 by 25? Is there any other side lengths that could be true? And the answer is yes, because you just have to think, what other two numbers could get you 300? Now you could say the side dimensions could be 1 by 300, or 3 by 100, or 5 by 60. Okay, something, any one of those would be a counterexample. All right, so those would be the links. These could be potential links for a rectangle without being the 12 and 25. All right. In geometry, biconditional statements are used to write definitions. So your third buzzword is definition. And the definition for a definition is a statement that describes a mathematical object and can be written as a true biconditional. So we're not just going to say like a book is something with words in it. We're going to say with deeper meanings to it, to where only certain things can happen. And we'll kind of get into that with more and more examples in class.